Today we are going to review what we've learned about conic sections. At the top of the review, you'll see a chart. It's the same chart that was in the last couple homework assignments, and that chart will be on the top of your test as well. The first group of problems ask us to do two things. They want us to find the distance between the 2 points and then to find the midpoint of the point. When we learned about distance, we did learn a distance formula that some of you chose to use. And if you still choose to use that, that is absolutely fine. It is the square root of x1 minus x2 squared plus y1 minus y2 squared. If you choose to use that, however, you need to know it. Because as it's not printed on the review, it's not going to be printed on the test either. So the way that I said I usually prefer to do these is instead of memorizing a formula, I plot the points. So I'd plot a point at 0, 0, and I would plot a point at 4, 4, and make a triangle out of it. And then we can just apply our Pythagorean theorem so we don't have a new formula to memorize. So the distance squared would be equal to 4 squared plus 4 squared. Or distance squared is equal to 4 squared is 16. 16 plus 16 is 32. Take a square root. Answers should be given as simplified square roots when possible. So we would need to think about any perfect squares that divide into 32. Well, 16 does. 16 times 2, so that gives us 4 square roots of 2. Or you might actually even recognize that triangle from back when we did our trig studies. That's a 45, 45, 90 triangle that if the two sides are the same, it's isosceles, makes it a 45, 45, 90. You also, for the problems, need to give the midpoint. The midpoint is adding together the x's and divide by 2, comma, adding together the y's and divide by 2. So that gives us a midpoint value of 2, 2. I'm going to go down to number 3, and I'm actually going to change this to a positive one. I think that's what I meant it to be. Let me grab my calculator quickly and make sure. Yeah. Okay, so then I'm going to plot those points. So the first one goes over 8 and up 24. And the second one is just over 1. So then the bottom side of this triangle has a length of 7. And the vertical side has a length of 24. 7 squared plus 24 squared equals
Please pardon this interruption.
C squared.
There seems to be some confusion in regards to Senior Servant Day. Students are not.
All right, so then we can grab a calculator to add up what that is. The 7 squared plus the 24 squared, that's 625. And when we take a square root of that, that actually turns out to be a nice number. 25 is the distance there then. For the midpoint, we add together the x's and divide by 2. And we add together the y's and divide by 2. So that's at 9 over 2, or 4.5, comma, 12. Go ahead and take a couple minutes to try problem 2 and problem 4. For question 2, when we plot them at 0, 0 and 4, negative 4, we get a triangle that has sides of 4 and 4 again. So this really turns out to be really the same picture as problem number 1, it's just flipped upside down. But the lengths are all the same, since lengths don't matter whether they're positive or negative. So our distance is still 4 square roots of 2, just like it was in the other one. The midpoint, however, when we add it up, it needs to fall in the middle down here, so that's going to be at a positive 2, negative 2 this time. For number 4, when we plot the point at over 5 and up 4 here, and then back 5 and down 4 here, our triangle has a side of 8 vertically and 10 horizontally. So we'd want to do a Pythagorean theorem for that. Our distance squared is equal to 10 squared plus 8 squared. So that's 164. We'd want to take a square root of that and look for any perfect squares that divide into there. So I know for sure 4 does. And it's 4 times 41. 41 can't break down anymore, so that means it's 2 square roots of 41 for our distance there. The midpoint, if we add together the x's, we get 0, and add together the y's, we get 0. Dividing by 2 still gives 0. So the midpoint is the origin. Questions on distance or midpoint? The next group of questions wants us to write an equation for the conic section. You can use the chart that's at the top of the review because it will also be at the top of your test. So all of the information in the charts about the standard form of the equations you do not need to have memorized. For number 5, I'm going to go ahead and sketch what we're given. We're given that we have a vertex at 0, 0. The vertex in the formulas for parabola gives hk. And we have a focus at negative 2, 0. So our focus is here, means our parabola looks like that. It's a left facing. So then in the chart, we want to choose the format for the horizontal facing parabola. The horizontal facing parabola is y minus k squared equals 4p x minus h. H and k are the vertex of the parabola, so those are both 0. P is the distance from the vertex to the focus. So in the picture, that distance is a negative 2 because it's left facing. That gives a negative value there. Left and down are negative directions. So we'd want to plug in a negative 2 for the p value. And that gives us then a final answer of y squared is equal to, since it's minus 0, we don't really need it. If you wrote y minus 0 squared, that's totally fine. It's still correct. We just don't really need it since it's a 0. Negative 8, and then again just the x. Or if you wrote x minus 0, that's totally fine. For number 6, we have a parabola again. Vertex at 0, 0 again. And our directrix at y equals negative 3. Is y equals negative 3 going to give us a horizontal or a vertical line?
Horizontal.
So what we want to do is go to that value of y is negative 3 and then make a line at that value. So it's going to give us a horizontal line, which means our parabola is going to have to face up to face away from that directrix. And our focus would then have to be at positive 3 because it has to be opposite of the directrix. So this one's vertically facing. So the vertical facing parabola in the chart is x minus h squared equals 4p y minus k. Our vertex at 0, 0 gives us h and k values of 0 again. And p is the distance from the vertex to the focus. Since this one faces up, up is a positive direction, so we have a p-value of positive 3. Plug that in there. We get a final answer of x squared is equal to 12y.
So P is the focus.
P is the distance from the vertex to the focus. So we don't necessarily just want to take the number in there unless our vertex is at 0, 0. Otherwise, we'd want to think about measuring a distance. Circles I don't typically bother drawing because there's only one form of the equation, so I don't need to decide whether I need a horizontal or a vertical equation for it because it's just a circle. It's the same in every direction, and that's x minus h squared plus y minus k squared equals r squared. Our center is our hk, so those are both zeros. And our radius is r, which is 5. So that gives me just x squared plus y squared equals 5 squared, just 25. And if you left the zeros in there and you wrote like x minus 0, I'm not going to mark you wrong. That's totally right. We just don't really need it. Questions on those three?
Do you want us to simplify them down? Would you prefer it?
I don't really care. I mean, I want you to simplify arithmetic in the sense of like, don't leave it at 4 times negative 2 or 4 times 3 or 5 squared. Like, actually do that. But if you leave the zeros in there so it still is in the perfect standard form format, that's fine. Okay, next we have a circle with a center at 2, 2 and a radius of 3. So our circle equation, again, is x minus h squared plus y minus k squared equals r squared. Our center gives our h and k, so this time they are 2. Our radius is our r value, so that's 3. So then we get x minus 2 squared plus y minus 2 squared equals 9.
What is this equation finding?
A circle.
Well, I know that, but is that just like this circle?
Yeah, that's just like y equals mx plus b is a line, that equation's a circle. Yep, if we would start picking like x and y values and plugging them in, they would plot out a circle. For the next one with an ellipse, I'm going to go ahead and plot the points. So we have our center at 0, 0. That's going to be our h and k. I have a vertex over 0 up 8, which means it's symmetrical. I must have one down at negative 8 as well. And I need a covertex over 6. Means I must have one symmetrically back at negative 6 as well. This is an ellipse, so we connect it around. The ellipse equation says x minus something squared over something plus y minus something squared over something equals 1. We have our h and k to plug into those parentheses, which in this problem are both zeros. And underneath the x and the y, I don't worry so much about what's a and what's b. In the chart, it gives you different options for whether it should be a or b, depending on whether it's horizontal or vertical facing. But just from our picture, we want to take and say, if we're measuring something in a horizontal distance, horizontal is x. So what do I do with that information? Put it under the x, but before I put it under there, I need to square it. So 36 goes under the x. And under the y goes 64. Hyperbola centered at 0, 0. That's our h and k again. We have foci at positive and negative 4, 0, and vertices at positive and negative 2. So this gives us a horizontal facing hyperbola, since it's opening left and right, and the horizontal facing should have the letter x come first. Okay, so the chart gives the two options for the horizontal and vertical hyperbola. Doesn't really matter, again, so much what we call A and what we call B, but in a hyperbola, the letter that comes first determines the direction, so x needs to be coming first for the horizontal. H and K are the center, which in this problem is 0, 0. Then in our picture, we can take a measurement from the center to the curve, and that gives us some information about the equation. And what does that tell us?
The
What letter does it go under?
X.
X, because it's a sideways measurement, and what do I put under the X?
4.
4, because I want to square what I see in the graph. So the distance there is 2 in the X direction. We want to square it when we put it into the equation, so a 4 goes under the X. I don't have any information about the Y direction in this problem. So from the picture, I can't determine what to put under the Y. So the only other important measurement we could take is from the center to the focus. Center to focus distance is C. Lots of C's to try to help you keep that straight. Center to focus distance is C, which is 4. And in the chart, it gives you an equation that c squared is equal to a squared plus b squared for a hyperbola. So c is 4, so that's 16. A squared is what we already know, and b squared is what we need to know. So 12 is b squared, and that's what we need to plug into the equation then. Questions? The last group of problems is graphing. To be able to graph, your first job is to figure out what it is that you're graphing. Which type of conic is it? And you have that chart again, so you can look at the equations and try to match them up. What does this look like according to what we know? We also talked about how we could tell by looking in terms of if there's one letter squared or two letters squared, if we're adding or subtracting. So in number 11, we're adding. They're both squared, and they have the same multiplier. It's just a plain x squared and a plain y squared. So what does that mean this is? Is it? I know some of you know it because I can hear you saying it, but I'm just still going to wait. Thank you. It's Friday, but wake up. Okay, so it's a circle. They're both added, they're both squared, and they have the same thing multiplied in front of them. So that means it's going to be a circle. It's the same distance wide as it is tall. Our center is going to be where? 0, 0, because there's nothing being added directly to the x or the y. So there's no h or k in this equation. So we're centering at 0. And what's our radius going to be? 6, because we take the square root of that 36. So we go 6 in each direction from the center. And, whoa, connect around with as circular of a shape as you can manage. What's 12? A parabola. Only one of them is squared. So when only one letter is squared, it's a parabola. So then when we look at the chart, since it's the y that is squared, what direction is it?
Horizontal.
A horizontal. Parabolas behave a little bit backwards of what we'd expect. We're used to y kind of meaning a vertical direction, but parabolas actually act a little bit backwards of what we expect there. So this is a horizontal facing parabola. Where's the vertex going to be? 0, 0, because there's nothing being added directly to the x and the y. So there's no h and k. So our vertex is at 0. And the standard form then would be y squared is equal to 4px. So what does that mean our p-value has to be here? 2. If that 4p is supposed to be equal to the 8, that means our p-value must be 2. Since it's facing sideways, we go 2 to the right to make the focus, 2 to the left to make the directrix, and draw in the parabola kind of medium wide.
So P is how you know how wide.
The bigger the p-value, the wider it is. What is 13? A hyperbola. How can we tell? The subtraction. So since we're subtracting, this has to be a hyperbola. It's not in standard form, though. For standard form, ellipses and hyperbolas need to be equal to 1. So we need to begin this problem by dividing everything by 25. Where is this hyperbola centered? 0, 0, because there's nothing being added or subtracted with the x's, so there's no h and k. Under the x is now a 25. Take the square root, so that is 5, and I'm going to go 5 in each direction for the x. Under the y is a 25, so I'm going to go 5 in each direction for the y. For a hyperbola, we make a box at those values and draw in our diagonals. I need to fill it into 2 of the sections. How can I tell which 2 sections to fill it in? X comes first, so that means we fill it in the x sections, or the sideways sections. $14 looks almost exactly the same as 13. What's going to be different? It's going to go in the top and bottom sections. All the measurements are the same. All the numbers are the same. So it's going to give us exactly the same picture in terms of our center and the box and the asymptote. But when we draw it in, we're just going to draw it into the top and the bottom sections because the y comes first. Number 15 is going to be what? An ellipse. We can tell that because they are both squared. They are added, but unlike the circle that we saw, they have different numbers in front of them. So that means that we're going to be stretched out in one direction, either tall or wide. Whereas if the multipliers are the same, then it's equal in all directions. For an ellipse, we need it equal to 1. So we're going to divide this by 144 across. When we reduce, then that gives x squared over 16 plus y squared over 9 equals 1.
You give this problem a lot.
Yeah, there's a lot of numbers that show up because they're like perfect squares multiplied together to make a perfect square, and so we end up seeing the same numbers a lot. Where's it centered? 0, 0, because there's nothing added or subtracted to the x's and y's. Under the x is a 16, square root it and go 4. Under the y is a 9, so square root it and go 3. And since this is an ellipse, we just connect around.
Wait, what's that?
Up and down is 3
Oh,
because of 9. Last one, what is 16 going to be? An ellipse. They are both squared and they're added together and they have different things underneath them, so it's going to be an ellipse. Where is it centered?
1, 0. 1-0.
I like the 0.
Negative.
Negative 1, 0. It's the opposite to the stuff in the parentheses because standard form is x minus h and y minus k. So it's the opposite of what we see in the parentheses. So we're going to center this at negative 1, 0. Then from that center, since under the x is a 9, I'm going to go 3 in each direction. And under the y is a 1, so I'm going to square root and go 1 in each direction.
It's a small ellipse.
And we get a small ellipse.